Hello, good morning. This is section 4.6 and we're going to be talking about the word problems and such with distance, rate, and time. I do need, or if you have not already done so before you watch this video, you need to download the packet that says PDF Vilsic MTE, no, it says Vilsic Unit 4 PDF. And we're going to be working problems out of here. I have these ones that are in that packet so that we don't have to write the problem down or write this chart down at least. So please, before you watch this, go print these out. So if you haven't done so already, pause this and go print that out. So, all right, so if you already have this ready and you have this in front of you, the page that we have is, it says, 2 cars leave at the same time and travel in opposite directions. One travels east at 47 miles per hour and the other travels west at 41 miles per hour. When will the 2 cars be 264 miles apart? Yes, it's the proverbial train, when will 2 trains arrive at the station kind of problems that we're going to deal with. Now, if you'll follow my example, they won't be that difficult. What I mean by that is we always use a chart when we are working word problems and distance, rate, and time. So we will always have this. Remember that distance is equal to rate times time equals distance. That is the formula always, and that's what we're going to be using. Just want to make sure we can see that good there. Let me slide you a little further closer. Okay, so when we have rate times time equals distance, that means if we have car 1, we're going to have however fast they're going for however long they drive equals the distance they drive. Okay, so this one, I read it one time and I'm going to read it again. It says 2 cars leave at the same time and travel in opposite directions. One car travels east and the other car travels west. When will they be 264 miles apart? So I have 2 cars. Car 2. So I have this chart here. We're always going to use this rate times time equals distance. And I'm going to change colors here a little bit just to make things a little bit more interesting. So here we are talking about car 2. This is car 1. This is car 2. Now I'm going to read it one more time, and it says 2 cars leave at the same time and travel in opposite directions. That means if they start here, this is their starting point. Start point. Car 1 is going to go this way. Car 1. Car 2 is going to go this way. Car 2. So here's the starting point. They're going to go in opposite directions. Car 1 is going one direction. Car 2 is going the opposite direction. And it says, when will they be 264 miles apart? That is the distance from here, this point right there, all the way over to this point here is 264 miles. That is not car 2. See, car 2 didn't go 264 because car 2 only went from here to here. This is the distance car 2 went. Car 1 went from here to here, so it's not made up of 264. The 2 cars combined, their distance is 264 miles. So we always need a chart and we need an equation. This picture is where we're going to find our equation because it tells us that the equation that we have is car 2 plus car 1 equals 264. That is our equation that we're going to use right there. Okay? All right. So back up here, where are we going to get the information for car 2 and car 1's distance? This is their distance here. The distance of car 2, distance of car 2, and the distance of car 1 is equal to 264. So where do we find that information? We go back to our packet and we read it again. It says 2 cars leave at the same time and travel in opposite directions. The same time means that they're driving, if they drive for 1 hour, they're both driving for 1 hour. If they're both driving for 2 hours, both driving for 3 hours, neither one of them stopped and took a break or anything like that. It's not like car 1 went, you know what, I think I'll stop at McDonald's and get me a cup of coffee and take a 30-minute break and then keep driving. They both left and they both drove for 2 or 3 hours, or however long they drove. So one car travels east at 47 miles per hour. The 47 miles per hour is our rate. So the one driving east, and since I kind of considered one to the right east, I'm going to call that one up there car 1. So he's 47 miles per hour. And the other car travels west at 41 miles per hour. So I put the 41 right there. Now I still have 2 blanks, actually 4 blanks in my thing here, right? Well, remember that car 1, this information right here is all about car 1. They're talking about this distance here. So how long did they drive? Did it tell us anything about how long car 1 drove? No, so I'm just going to give it a variable, and usually we just call it T for time, because it didn't say it drove for 2 hours. It didn't say that it was 2 hours less than the other car. It just said they drove the same amount of time. So we just give it T. Now to find the distance of car 1, it has nothing to do with this 264. I mean, well, it kind of does, but it has nothing to do with it. I get my distance from here. I say rate times time equals distance. Rate is 47 times T equals my distance. So what is 47 times T? 47T. So my distance for my car 1 is just 47T. 47 times T. Unless they tell us car 1 drove 15 miles. Car 2 drove 35 miles. We cannot put an actual number in there unless they're telling us the exact number. A lot of times people want to go and put 264 up there. They didn't tell us car 1 drove 264 miles. They said that when will they be apart 264 miles. So car 1 didn't drive 264 because it's combined car 2 and car 1. So moving down here to car 2, let's read it. It said that it drove 41 miles per hour. Its time is still T because they drove the same amount of time. They didn't start and stop or anything. They just got in the car, said goodbye, I'll see you later, and they just drove. And how long will it take them to be 264 miles apart? So to find its distance, remember it's here, it says rate times time equals distance. So rate times time equals distance. What's 41 times T? 41T. Okay? It's always going to be that way. If you set this chart up, it's going to be the rate times time equals distance every single time. Sometimes our times might be a little bit different. We'll see some problems like that. But it's always rate times time equals distance. So now we have our distances for each car, because this is the distance for car 1, this is the distance for car 2, and we have our formula. So I'm going to put this right over here. I think I have room on my screen. And I say car 2 plus car 1 equals 264. What's the distance for car 2? Car 2 distance is 41T. Be careful with these T's and pluses. I like to put a little tail on my T's because sometimes they look like plus signs. What's the distance of car 1? Right up there. 47T equals 264. So now I have an equation. I could just add 41T plus 47T and get 264. So 41T plus 47T would be 88T equals 264. We're going to divide by 88. And T is equal to what? What do we get? I'm going to come over here on the computer. And I'm going to see, because I don't have a calculator. And y'all get to use a calculator, so why don't I get to use a calculator? If the computer ever comes up. Maybe 3, let's see. 88 into 264, would it be 3? 3 times 8 is 24. 24, 25, 26. Yep, I'm faster than the computer, it looks like. 3. What does T stand for? Hours, so that's 3 hours. That means that the first car drove for 3 hours. The second car drove for 3 hours. And I want to make sure I'm answering the question, so I'm going to go back and read the question to make sure I answered the actual one they asked for. So it said 2 cars leave at the same time and travel in opposite directions. One car travels east at 47 miles per hour and the other car travels west at 41 miles per hour. When will the 2 cars be 264 miles apart? They said when, so that means time. So my time is 3 hours. 3 hours. They will be 264 miles apart. Now, I know this can be very overwhelming sometimes. Just don't get overwhelmed. Don't give up. Remember, this is a video. Well, of course, you know it's a video. But you can go back and replay this again if I went through it a little fast. That's the nice thing about the video lectures. I am going to move on to the second problem, though. Actually, I think I'll break it up into another video. So I'll see you in just a minute. This is part 1, so we'll see another one because I don't want it to be too long. All right, have a nice day.